We've been solving systems of equations for a while. We're now ready to learn a really awesome method that I think you're going to love. We're going to solve systems by elimination. So let's write the word elimination. This is called the elimination technique. And the warm-up question is, what does it mean when you eliminate something? Well, when you eliminate something, you get rid of it. Okay? You make it go away. And you'll see why we call this the elimination method right now. So I'm going to solve this system by elimination way faster than graphing, more accurate than graphing, and way easier than substitution. But you do have to know how to do substitution in order to do this. So here's what I'm going to do. This is a true equation right here, and this is a true equation right here. And we know that if we add two true equations together, we're going to get another true equation. So let's just add these together. So if I take x and subtract x minus x is 0x. I'm not even going to write that. 2y plus 4y, that's going to be 6y. And then negative 2 minus 1, that's going to be negative 3. And then I'm just going to divide both sides by 6, and I get y equals negative 1/2. Now that looks really awful, but we can deal with this. We know that y is equal to negative 1/2. If we know that y is equal to negative 1/2, then wherever there's a y, if an equation asks for a y or somebody says, hey, what's y, we can tell them that it's negative 1/2. So here's what we're going to do. I'm going to come back here to one of these original equations. I'm going to take this first one because I think it looks the easiest. And I'm just going to say, look, instead of putting a y right there, I'm going to put what y equals. So I'm going to rewrite that first equation like this. Again, when we plug things in, we always do it in parentheses. So this is going to be negative 1/2 equals negative 2. So here's what we've got. X, positive times a negative, negative. 2 times 1/2, that's going to be a 1, equals negative 2. So we're going to add 1. So we end up with x equals negative 1. There's the other part of the answer. Now that quickly, we are done with this. This had a fraction in it. We've got both answers, and we did it really quickly, and we did it really accurately. That's the answer right there, okay? So in order to use this elimination technique, we need two things. So to eliminate a variable, you need the same coefficient, and you need opposite signs. So we're going to come back here and we're going to take a look at this, and I'm going to show you where this comes in. You'll notice that when I added these together, the thing that we got rid of, the thing that was eliminated, was the x, and here's why. This coefficient was a positive 1. This coefficient was a negative 1. They're the same coefficient. They're both 1s. They just have opposite signs. So when you put those together, they're what we call additive inverses. They're going to cancel off to be a 0. They're going to be eliminated. And that's the key to being able to do the elimination technique. It's very quick. It's very easy. We've got to have the same coefficient, and we've got to have opposite signs. So let's take a look at example 2a. And the instructions for all of these are solved by elimination. So we want to eliminate either the x or we want to eliminate the y. It doesn't really make any difference, but that's the question, is which variable should we eliminate? Okay, we usually want to have the smallest numbers. So whatever is going to keep it with the smallest numbers, and any variables that already have opposite signs. That's going to be an advantage for us. So we want to keep the numbers fairly small, and we want to take advantage of the fact if they already have opposite signs, let's go ahead and use that. So if you take a look at this right here, this is a 3 and this is a 4. We could turn both of those into 12. That wouldn't be too hard, but we'd have to change them both. If we take a look at the 10 and the 5, this one's already negative, and it would be really easy to turn this one into a negative 10. So that's what we're going to do. We're going to take this, and we're going to multiply it by a 2. So this second equation is going to turn into this. It's going to be an 8x. It's going to be a negative 10y, and it's going to be a negative 34. So you'll notice that all we did here is we just doubled each one of these. 4 times 2 is 8. 5 times 2 is 10. Got the negative there. 2 times 17 is 34. Now I am going to cross this one out for the time being so you can't see that. And then we're just going to add these together. So take a look here. We've got 3x plus 8x. That's 11x. We've got negative 10y plus, minus 10y. So 10y minus 10y, that's going to be 0y's. Those are going to go away. And then we end up with negative 10 minus 34. That's going to be negative 44. Looks good. Okay. And we're going to divide both sides by 11. So we get x equals negative 44 divided by 11 is negative 4. Okay, there's the answer right here. Now when I say the answer, That's the answer for x. It's not the answer for the whole thing. So now we have to go back and we have to figure out what y was. Well, remember I said you can't use this nice easy technique of elimination without knowing how to do substitution. So we want to take this and we want to plug it back into one of these equations. Now, all three of these equations that we have written down here, all three of these are true equations. We want to take this and we want to plug it back in. It doesn't make any difference which one we plug it into. We usually just want to pick the easiest one. And easiest one is probably the one with the smallest number and the fewest number of negatives. So here's what we're going to do. I'm going to plug it into this one right here. And the reason I'm going to plug it into that one is there's only one negative in it. These are all fairly nice numbers. This one has two negatives and one of the numbers is negative 17. That's probably a little harder to work with. So here's what we're going to do. We're going to write down 3x is negative 4 plus 10y equals negative 10. Now again, I'm going to pause for just a second and make sure everybody's clear on what's going on here. I am literally rewriting this first equation right here. Let me highlight that. Oops, let me highlight that. And highlight this. There's the 3. 3's right there. X is negative 4, so I'm just putting a negative 4 in its place. There's the plus 10y. There's the equals negative 10. Now I can go through and I can solve this. Okay? So we'll go through and solve this. So this is negative 12 plus 10y equals negative 10. We're going to add 12, so this is 10y equals 2, and we're going to divide by 10, so we get y equals, let's reduce this, this is going to be 1/5, and there's the other part of the answer. So now all I have to do is I just have to write this down as an ordered pair, so this is going to be negative 4 comma 1/5, put it in parentheses, circle it, and we're done. So you can see that even when we get some ugly numbers for answers like that 1/5, it's still relatively easy to work with and get an answer to this. So let's take a look at the next one. Again, we want to get rid of one of these variables. We either want to get rid of the x or the y. So we want to keep the numbers fairly small. We want to take advantage of the fact that some of them may already have opposite signs. So let's take a look here. I could turn the 8 and the 5 into 40. But let's turn these into, 3 and 5, I could turn those into 15s. Now, when I've got the room to do something like this, here's what I'm going to do. I'm going to write the new ones off to the side, so I'm just going to put a little arrow here. I need to make that a 15, so I'm going to multiply by 5. So I'm going to distribute that through to all of those. I'm basically multiplying every term on both sides by that, so that's going to be negative 15x. This is going to be, let's see, what would that be? That's going to be plus 40y and negative 15 over here. So let's do this one. We've got a negative 15x right here now, so I need to turn that 5 into a positive 15 so it can eliminate, so it can cancel that out there. So we're going to multiply by 3. So I'm going to multiply like this. So that's going to be a 15x, and then we're going to multiply here. That's going to be a negative 15y, and then we multiply here, and that's going to be a 90. So let's see what we've got here. When we combine those, the x's go away. They cancel each other out like we want. This is 25y. And then on the other side, this is going to be 90 minus 15 is 75. So we just divide by 25, and we get y equals 3. So we've got that part of the answer. And now it gets a little bit interesting with a problem like this, because there are actually 4 true equations here. Let me highlight them for you. That's a true equation, that's a true equation, that's a true equation, that's a true equation. So we want to plug this into one of those. We want to pick the easiest one, smallest numbers, fewest number of negatives. I would probably plug it into this one right here. So I'm going to take this and plug it in right there. So this is going to be 5x, whoops, minus 5 times y, and y is 3, equals 30. So this is going to be 5x minus 15 equals 30. So we're going to move that 15 to the other side by adding 15. So 5x equals 45. We're going to divide by 5, so we get x is equal to 9. So there's the other part of the answer. We'll come back here and we'll write it as an ordered pair. So this is going to be 9 comma 3. So after all of that mess, changing both equations and stuff like that, we still get a fairly nice answer of 9 comma 3. Now, moving on to these last couple, let's take a quick look at these. These both have asterisks on them, probably for a reason. So let's go ahead and take a look at this right here. On this, we want to eliminate either the x or the y. I think that x is going to be pretty easy to get rid of, because all I need to do is turn that into a 2. So let's do this. Let's multiply this one by 2. So if we do that, we're going to multiply here, here, and here. So we end up with, this is a 2x, this is a minus 10y, and this is a 22. So when we combine those, and again, we've already used this one right here, so I'm going to kind of cross that off so you can't see it. These are the ones that we're putting together. There's equation number 1. We're going to add equation number 2 and equation number 3 together. So let's see what we get on that. Negative 2x plus 2x is 0. 10y minus 10y, that's also going to be 0. So lo and behold, both of them go away. And then on this side, negative 12 plus 22, that's going to be a 10. Now, I'm hoping that you remember what happens in a case like this. If the variables go away and the numbers that are left don't equal each other, that means something. It means something about how true we can make the equations. So there's no way that we can make this true. So this is no solution. Now, you might want to think about what that means. Another word for that would be inconsistent. And if we were to graph this, remember those 3 things that can happen? Those are going to be parallel lines. They're gonna be have the same slope. They're going to go in the same direction, but they're never going to cross. Okay, so just something to keep in mind. You don't have to say inconsistent. You don't have to know that they're parallel lines. We can just say no solution, and we're good to go. So let's take a look at this next one here. Again, this one has an asterisk by it. Let's keep the numbers fairly small. We could make the y's into like 30 or something, but let's keep this small. Let's make these into 6s. We've got a 3 and a 2. We could make those both into 6. So I'm going to multiply this one by 2, and I'm going to multiply this one by 3. Now, watch what happens here. I'm going to end up with, I'll put them over on this side right here. This is going to give me 6x minus 30y equals 36. Now just double check me here. 2 times 3, 6. 2 times negative 15, negative 30. 2 times 18, 36. Now let's do this one. And here's why we did the 3, because it already had a negative. We were taking advantage of the fact that they're opposites. So 3 times negative 2, negative 6x. 3 times 10, that's going to be positive 30y. And 3 times negative 12, that's going to be negative, and 3 times 12 is 36. And some of you might be able to see what's going on here. The x's are going to cancel out. The y's are going to cancel out. So we get a 0 over here, and those cancel out. Now, what does that mean? These two numbers are equal to each other. So the way we used to say that is we would say they are infinitely many solutions. Infinitely many solutions. So we'll go ahead and circle that. Do you remember if there's a name for this? It's something kind of like this. It's not inconsistent because that means there's no solution. This has solutions. This is consistent and dependent. Consistent and dependent. Consistent and dependent. Now you don't have to know that, but it would be really cool if you could tell me what this graph looks like. If you were to graph those, if it has infinitely many solutions, that means those two lines are right on top of each other. All right, rate yourself on that scale. Get started on the assignment. Good luck on that. Please make sure you ask if you've got questions. Thanks.